Okay, our first review problem deals with frequency distributions, and here we're given the amount of gasoline purchased by 28 drivers, and they're giving us the numbers to whole numbers to dollar amounts. So take a minute, enter the data into your calculator, and then what we need to do is we need to construct a frequency distribution. Basically, what that is a chart in which we're going to set up intervals and then count up the number of numbers that are in those intervals. So take a minute, enter the data into your calculator, and we'll put the pictures in the box. Always make sure your n matches the number of data that you're given. In this case, they give us 28 data. And we need to construct a frequency distribution. And what we're going to do is we're going to use this 5-number summary, the last 5 values that were given, to help us set up these intervals. The minimum value of 2 is always the starting point of the first interval. So we always start off our first interval at the minimum value. Now what we need to calculate is how big of an interval, the interval size, what they call the class width. And in order to do that, what we're going to do is we're going to calculate the range of the data, and we're going to divide that by the number of intervals which the problem will tell you to set up. Here, you're asked to set up 6 intervals. So we're going to take the range of the data and divide it by 6. Well, our range is our maximum minus the minimum. So here the range of the data is 18 minus 2, or 16. So what we're going to do is we're going to take the maximum minus the minimum, the range, 16, divide that by the number of intervals. Now when we do that on our calculator, we're going to get 2.6 repeating. And what you always need to do is you always need to round that value up based on the data that's given to you. Well, here you're given whole numbers, you're given integers. So we're going to round up 2.6 to the nearest integer, and that's going to be 3. So that tells us that our interval size, our class width, is going to be 3. So we're going to take this minimum, which we said was 2, add 3 to it. That means our next interval is going to start at 5. Then we'll add 3 to that. Our third interval is going to start off at 8. Then we'll add 3 to get the starting points of all of the intervals. Now, we're setting up intervals. So since the second interval starts at 5, the first interval has to end at 4. The third interval starts at 8, which means the second interval has to end at 7. The fourth starts at 11, which means the third ends at 10. And you see how we use this 3 to get the starting points of the intervals, what they call the lower class limits. We're adding 3 as we go. Well, here we're going to keep adding 3 as we go. So 13, 16, 19. So we get our interval size, our class width, by taking the range and dividing by the number of intervals, and then you round up based on the data. Now what we're going to do is we're going to sort the data in order. So we're going to use our calculator to do that. So now our data is in numerical order. And now what we're going to begin to do is fill in the various frequencies. The first interval is from 2 to 4. So I basically want to count up my frequency. How many numbers are there from 2 to 4? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we say the frequency of that first interval is 9. Our next interval is from 5 to 7, so we'll count up the number of data from 5 to 7, and you include the 5 and the 7. So 1, 2, 3, 4, 5, 6. So what you're going to do is you're going to go through now each of the intervals and determine each interval's frequency. And since you know that you have 28 drivers represented, the sum of your frequencies should be 28. Okay, so I found all of my frequencies, and again, always double check and make sure their sum 9, 7, 6, that's 22, 25, 27, 28. So always make sure your sum of your frequencies adds up to the number of data that you're given. Next, what we want to do is determine the relative frequency. And the relative frequency is basically just the percent of the data that is in each interval. We know that there's 28 numbers. I want to know how many numbers are there from 2 to 4. Well, I know that's 9, but I want to know what percent of the 28 is in that interval. And the formula that you use to determine the relative frequency is you take the frequency and you divide that by the total. So since the first interval, the frequency is 9, we're going to do on our calculator 9 divided by 28. And this is going to be a percent, so we're going to express it as a decimal to 2 decimal places. So here the relative frequency of the first interval is 0.32, meaning about 32% of the data are from 2 to 4. Now we're going to find the relative frequency of the second interval from 5 to 7. Well, we know there's 7 data values in that interval, so we'll take 7 and divide it by 28. And we know that 7 over 28 reduces to 1/4, so that's a quarter. So the relative frequency is going to be 0.25. So you're going to take all of those frequencies and divide them by the total, in this case 28. And remember, for each, we're always going to go to 2 decimal places. So here's what your relative frequency column should have looked like. And lastly, we're going to fill in the cumulative frequency. And the cumulative frequency is basically just a running total of your data. What you're going to do is you're going to start off at the first interval and look at the frequency. So in this case, the frequency is 9. So we're going to say that the cumulative frequency is 9. Well, now our second interval from 5 to 7. Well, we know the frequency was 7, but I need a total. So what I'm going to do is I'm going to take the 7 and add it to the previous interval's frequency, and 9 plus 7 gives me 16. So we say the cumulative frequency is 16. The third interval, its frequency is 6, but we had the 7 and the 9 before it, so we get that sum of 22. Basically what you're doing is you're taking the previous cumulative and then adding the new frequency to it. So 16 plus 6 gives you 22. Well, the next interval, frequency is 3, so 22 plus 3 is 25. The next interval's frequency is 2. 25 plus 2 is 27. And then 27 plus 1 gives you the 28. And the significance of that 28 is that that is the total number of data. So you always want to make sure that that checks. Now what we're going to do is we're going to set up some histograms. We're going to draw some histograms. And the first one is the frequency histogram. So what we're going to do is we're going to use the intervals that we established and the frequencies that we found. We have 6 intervals because the problem said to use 6. So what we're going to do is we're going to break the bottom up into 6 parts. So I'll go to the midway point, put a line. Now I need a total of 6, so I'm going to break up each half into 3. So basically I broke up the bottom into 6 different intervals. And what I'm going to do is I'm going to label each interval with the starting point, the lower class width. I'll start in the bottom corner of 2, then I'll label 5, 8, 11, 14, and 17. What I need to now do is look at our total number in the frequency column. Look at our numbers. 9, 7, 6, 3, 2, 1. The biggest number I see is 9. So what I'm going to do is look at the biggest number that I have, 9, and choose an easy to read value that will make the graph appealing to the eye. And usually numbers that end with a 0 or a 5 do the trick. So since my biggest frequency is 9, I'll make my maximum up top 10. And then I'll break this side up. Maybe I'll label the midway point as 5. So now I know from the first interval, my frequency is going to be 9. So I'll go up to about 9, and I'll label my first section of the histogram. A histogram is a bar graph, but the bars are kind of attached. So here the second frequency is 7, so I'll go up to about 7, and I'll draw the second interval's section up to 7. The third interval is 6, so I'll go up to 6 for the third interval. Then I'll go up to 3 for the fourth interval, then 2, and then 1. So that's a frequency histogram where we use the intervals and then we use the frequency of each interval. Now what I'm going to do is I'm going to construct a relative frequency histogram. So I'm using the same 6 intervals, so I'm going to break up the bottom into 6. So I'll go to the midpoint and then go 3 in each half. I'm going to again label the starting points of my intervals as 2, 5, 8, 11, 14, and 17. But now what I'm going to be doing is I'm going to be using the relative frequencies which I calculated before. And just like I did before, I look at the biggest relative frequency, which in this case is 0.32. So as far as a maximum goes, I'm going to go up to, let's say, 0.40 or 40%. Maybe I'll label the midway point as 20%. I can even go to 30% and 10%, break the y-axis up into 10%. You just want to choose a scale that's going to make the graph easy to read. So now my first interval from 2 to 4, the relative frequency is 32%, so I'll go up a little bit past the 30% mark. So there's 32% for my first interval. My second interval, the relative frequency is 25%. The third, 21%. Then I have 11%, 7, and 4. And these two histograms should really resemble each other as far as the appearance goes. They're using the same intervals, but the frequency histogram is the number of data in each interval. The relative frequency is the percent of the data that's in each interval. Finally, what I'm going to do is I'm going to construct a cumulative frequency histogram. So just like before, I'll break the bottom up into 6 parts. And I'll label my starting points for the intervals. So 2, 5, 8, 11, 14, and 17. But now I'm going to be looking at the cumulative column. And in the cumulative column, the biggest number I have is the total number of data, which is 28. So I'm going to make my maximum go up to 30 because that's a nice round number. I can either go to the midway point of 15, or I can just keep going up by 10. So I can label my 10 and my 20 point. You just want to choose a scale that's going to make the graph easy to read. And now we'll go for our cumulative frequencies. For the first interval, the cumulative frequency is 9, so I'm going to go up to 9 for my first interval. Second interval, the frequency is 16, so I'll go up to 16. Notice again in the histogram, the bars are together. Then we go up to 22 for the third interval. 25 for the fourth interval. 27, and then 28. So there's my cumulative frequency histogram. So this is how we fill in a frequency distribution, that's the table, and then construct histograms. So for our next problem, we're taking a trip to Hawaii, and it says trade winds are one of the most beautiful features of island life in Hawaii. The following data represents the total air movement in miles each day over a weather station in Hawaii. So it looks like they're giving us some data here. It looks like they're giving us 16 data values. And what we need to do is we need to calculate the mean absolute deviation for the data. And what that means is this. Take a minute, enter the data into your calculator, and let's figure out what the average is. Let's figure out what our X bar is. Because the mean absolute deviation is how far from this average each number is going to be. Here, the mean to the nearest tenth is 47.7. So what the mean absolute deviation is how far from this mean each number is on average. For example, 26 is about 21 away from the mean. 14 is about 33 away from the mean. 18 is about 29 away from the mean. I want to know how far from this 47.7 each number is on average. So what we're going to do in order to calculate this mean absolute deviation is we're going to fill in a table. The first column of the table is labeled as X, and those are our data values. So one at a time, we're going to write the data values, 26, 14, 18, 14. We're going to write all of our data values in this first column. So the first column gets labeled as X. Our next column is going to be X bar, which was the mean of our data given. And here the mean was 47.7. So I'm going to write in this second column 47.7. And what I allowed you to do in class is just write the mean a few times and then label with an arrow to represent that you know each number in that column is going to be 47.7. Our third column is going to be labeled X minus X bar. What you're going to do is you're going to take each data value and subtract the 47.7. So So you'll take 26 minus 47.7, 14 minus 47.7. And to do this manually, when you have a lot of data, can be a little bit tedious. So what I showed you to do in class is a way of programming your calculator and those lists in statistics to do this calculation for you. So what you're going to do is this. Assuming you have all your data entered into list 1, what you're going to do is you're going to move the cursor and highlight all the way to the top of list 2. So that list 2 should pop up on the bottom. While the cursor is on this list 2, what you're going to do is you're going to press second and then the number 1 to bring up list 1 minus 47.7. Because what you want the calculator to do is take all of the data in list 1 and subtract 47.7. So when you press enter, what should happen is this. Your calculator takes every number in list 1 and subtracts the mean. But the key to do this properly is to make sure you put the cursor way to the top on top of the list column and then tell the calculator how you want to program that list. So now what we're going to do is we're going to label this third column with these data values. So take a minute and I'll start to fill in my data values as well. And you're going to have to scroll down to see the rest of your data. So that is how we fill in our third column. Our final column is the absolute value of the third column. So we label the fourth column as the absolute value of x minus x bar. What we want to do is just take all of the numbers that we have in the third column and make them positive. Because, for example, this first number, negative 21.7, I'm going to write positive 21.7. What does that mean? That means the data value of 26 is 21.7 away from our mean. It's 21.7 away from 47.7. 14 is 33.7 away from the mean. So 14 is 33.7 away from the mean data value. So what you're going to do is you're going to make all these numbers positive. And we're going to have to fill in this column in a second, but we're going to have to do this on our calculator as well. So move your cursor to the very top of list 3. And what you want to do is you want to tell your calculator to take the absolute value of every number in list 2. So while the cursor is on top of list 3, we're going to go to absolute value, which is math, the math button. Move the cursor to the right over to number. And then option 1, ABS, is absolute value. So while the cursor is on top of list 3, press the math button, press to the right to number, and then choose number 1 for absolute value. we want to take the absolute value of list 2. So then that's going to be second and then 2 for list 2. And when we do that, all of the numbers in that list 2 become positive. Now, we're going to write in all of these positive values. And I know you really don't need to have the calculator make the numbers positive. You know how to do that as well. But what you're going to do to calculate our mean absolute deviation is you're going to take the mean of list 3. So you have to have the calculator create the list for you so that you can take its mean. So I'm filling in my last column with all of the numbers in the previous column positive. Take a minute and do that as well. And to get your answer, you're going to go to your 1var stat test, use this list 3, use these positive data values, and find the average, which in this case is 31.4. So we say the mean absolute deviation is 31.4. That means each number in our data set is on average 31.4 away from the mean. So if we're living in Hawaii and the average trade wind miles is 47.7, we know that each day it could fluctuate by about 31.4. Each number in our data set is on average 31.4 away from the mean. So that's how we go about calculating the mean absolute deviation.